And today I'm going to present you my last result for my last model. Try to understand the natural dynamics of boreal forest using graph transformation. First of all, I come back in dynamics. What is dynamics? Dynamics, it's a way to understand some variable, like some population of trees in the forest or economical variable. And this variable, it's understood by time. And you see the change of this variable under time. You have different way to explain the timing model. The first one is the continuous way with differential equation, for example, where you see all the evolution of your dynamics at the t time and in every time you want to. Another way to model some time is discrete time event synchronous, where you have the succession of events, like you can see on the left with offspring, development, dispersal, calculate of reproductive potential, and is all the time the same the same trajectory of events. And in the T1 and T2, you have the same time in the T2 and T3. And in forest, I think is not in all the time the same way, because you have some importance of events, and the events are not, they don't have the same time between events. For example, if I take a fire can destroy a forest in 1 year. And if I want to see the growth of the forest is more on 100 years. And don't have the same time between different events, and these events have an impact of the dynamics of the boreal forest. It's why I use graph transformation. I use graph transformation. I use the set of rules, and all rules I have this on time. For example, here we have two rules to pass to the start to the last one. And we can see we have different time, N1, N2, N3, to pass time by time, and the different trajectory can change the time with the graph transformation. It's one of the important points of the model, I think. Other thing using graph transformation is the model is discrete event asynchronous and possibilists. Possibilists say we want to see all the possibilities of the trajectories when we begin with an initial state, and qualitative model. We try to integrating all biotic, abiotic, and anthropogenic components in a model and their interaction. The components is the node of the graph, and the interaction, the rule of the graph. The graph transformation is used like 50 years and described by Eric in 1970, and is one of the first time graph transformation are used in ecology. The objective of my model is to see if we can model a natural boreal forest dynamics since the post-glacial retreat and the pro-glacial lakes, to see the colonization of the trees on the south to the north. The second is see if we can discriminate different forest type with the GT model. As we can see in the, in the chart on the left, we can see on the top some black spruce woodland on lichen with a real frontier, and we can see black spruce forest on feather moss and mixed wood on sod, with not really frontier, but not something mixed between the two. And we want to see if we can see the third type of forest in our model. First of all, I tried to model a dynamic natural forest and focus on two natural perturbants. The first one, wildfire, and the second one, outbreaks of insects. We try after to have some state space and trajectories. For study the state space and trajectory, we base on comparison with paleoecological studies. Here, I just speak about wildfire and not the outbreaks because my model don't take in account the insect for the moment, the outbreak of insect for the moment. First of all, I explain you the model setting of a real toy model with some rules just for have an initiation to graph transformation. I choose 3 different nodes. 2 of them is northern species and southern species. And the third one is soil cover with 4 different states of the soil cover. Soil cover with lichen, with moss, with humus, and with nothing. With no lichen, no humus, no moss. It's bare soil. Now I try to input some rows. I say I focus on fire, and we can see a first row is the crown fire, and the crown fire burn the trees and the soil cover from the trees on the moss and the mixed forest on the humus. and we go to the bare soil. A second fire is the surplus fire. He burned the trees and the soil, but the trees don't die instantly, and the soil can restore. We can restore the soil, like the moss and the humus, and after the tree die. It's why we can see if we have trees and soil and soil cover, after we just have soil cover without trees, because the trees are dead, but not the soil. We have a third type of fire, it's the surface fire on soil only. When we have just moss on humus and problem of restoration trees, the humus and the moss can burn in summer without the tree. If you don't have tree on it, they can burn and go to the bare soil too. Now we have the recurrent fire. The recurrent fire is specific to the northern species. When we have northern species on moss, we can have one first fire, burn it, and when we have a sapling of northern species and a second fire on this sapling, we can burn the moss, and we have the apparition of lichen because it was of the impact of recurrent fire. We can pass to the black spruce on moss to black spruce on lichen. And another fire is just a ground fire on lichen soil, with the cover soil is lichen. When tree can burn with lichen, but lichen all time regenerate faster and stay on the soil, and it's why we can have some problem of regeneration. Now we're going to speak about the vegetation growth rules. For the rules for the vegetation can growth, we need a bare soil without tree in the soil, in the stem. Here we don't have northern species and southern species, and we can have the northern or southern species can grow with the associated soil cover, moss for the northern species and humus for the southern species. The third rule of vegetation growth is the vegetation growth on lichen. We can have the north species growth on the lichen if you have lichen on your soil. An important way is the initial state. Here, we choose an initial state as post-glacial condition, and species are present in the neighborhood of the proglacial lakes, but not in the zone we want to study. It's why the initial bare soil patch, the initial patch is a bare soil patch, and we work for this model just on one zone, on one patch. For the results, it's the type of result we can have with my model. And if I want to translate these results, we can have something like this, where we see in the right one, in the right part of this result, humus with mixed tree and humus only. On the left of this part, the berceau, the initial state in blue. On the left again, the northern species with moss or moss only. And on the left, lichen with northern species with lichen. What is important to see is the arrow between all the states. We can see here, we can cycle between mixed wood forest and black spruce forest on Fishermouth. But we can cycle with the black spruce woodland lichen. As we can see with this arrow, you have one arrow in unique sense without reversibility. For go to the black spruce forest on Fishermouth to the black spruce woodland on lichen. And it's important to see this reversibility in the model. I come back with the second model on the importance of reversibility. I did a second model setting where I just explain the complexification I do on the model, but not explain all the rules because it's too long, sorry. And I add some saplings on the northern species, and I use different northern and southern species. I put 5 different species in my model, the jack pine and the black spruce for the northern species, and the balsam fir, trembling aspen, and white cedar for the southern species. And I take the same soil cover on the first model and the same initial space. I put some other rules specific to sapling and all different species. And with this model, I have this type of results. It's interesting to see we have the same structure with on the right the southern species with all the different species. In the left part, we have the northern species with black spruce and jack pine on the left, and one just with jack pine on the top of left. Black spruce woodland on lichen in the top, and black spruce forest on Fishermouth on the left. Here we can see we can cycle with the mixed wood forest and the black spruce forest on Fishermouth, but it's depend of the covers, soil cover, the moss and the humus, but not with the lichen. And here again, we see the importance of the irreversibility of the rules. Go to the black spruce forest on the laser moss to the black spruce forest, black spruce woodland on lichen. In this state, we can see the state S1 in blue here. We can say this state space is a critical state space for the equilibrium of black spruce forest on Fishermouth and the mixed wood, because it is the only state who you have the rules to pass to the first equilibrium to a second one with irreversibility. The rules can be applied in other way and don't go in irreversibility. And in the state S1, you can have other trajectory for stay in the equilibrium. The importance for the irreversibility is the combination between a space and a rules. Now, if I come back to my discussion, to my objective, sorry, I can see the first question: could we model the natural boreal forest dynamics in the post-glacial breached of the post-glacial lakes? We can say yes, but we need more information with specialization of the model. For the moment, we don't have explicit specialization. The second one is we can discriminate different type of forest with GT. And here I want to say yes again, because we see the different category of forest explained in my model. The Woodsmith forest, the black spruce forest on Fishermouth, and on the top, the black spruce woodland on lichen. And we can see the irreversibility of the rules can be explained the real frontier and not the mixed frontier on the north between the black spruce forest and the black spruce woodland. What I want to do in short-term perspective, I want to input the outbreaks, the spruce budworm outbreak in my model and do some spatialization and just keep the model with natural disturbance and natural dynamics. And in second and intermediate term, I want to keep my model with natural disturbance and natural dynamics and add some management logging for compare the new model and the new state space and trajectories can I have with not only paleological data, but with forestry data and forest cover data. Thanks for your attention.
Merci beaucoup, Boris. Thank you very much, Boris. Are there any questions for Boris? Y a-t-il des questions pour Boris?
Indeed, I have one. No, there is Wei Wang. Okay, we have some questions already.
So Wei, the first question. Oh, do you want to?
I see the I see the question. No problem. Are there any climatic components involved in your models? For the moment, no, but we can add it, and I think it's important to add it for when we complexify the model. But for the first one, I didn't need climatical components to just have to retrace the post-glacial outbreak, the post-glacial, colonization. Second question, how to do the parametrization in this model? The parametrization is something qualitative, and I based on just literature. And what is interesting is the model is possibilist, and we can see without the rules and with the application of rules. And for just parameterization of the model is more about some when I show you the, I come back just, sorry. I'm gonna show you. I come back on the rules. Sorry, I don't know. Did you see again my screen? Here we have rules, and the parameterization of rules is just say the trees can burn without the soil cover, and it's one of the parameterization is really simple, and we don't have to parameterize with something quantitative. We just need to parameterize the model with qualitative things. I don't know if I really clear with this answer, sorry.
We have two more questions by Yves Bergeron and by Sylvie Gauthier. Yves, do you want to ask your question first?
Yes. Boris, I might not have understood exactly the way your model is working, but fire is a random process. How do you integrate these stochastic effects in the dynamic of your system? Because of course it could be very variable.
Yeah, of course. It's why I try again with the possibilistic of the model. The model see all the trajectory than the initial state, when the fire is on and when the fire is off too, and you see if the fire can be applied or not. And we don't have something like stochastic, just possibilistic. We can see the trajectory with the fire and without the fire, or with a lot of fire or not a lot of fire. And it's different than the stochastic model. We don't see and don't see the stochastic of the fire at the beginning of the model, but after, on the result, we take the trajectory and see where is the trajectory is possible or not, because okay, I see in this trajectory I have too much fire, and it's not possible to have something like 1,000 fires in 1 year. It's not possible, and it's another problem, and it's not a problem for me. It's more interesting. It's another way to work with this model. We need to really focus on the end trajectory of my model to see where is the possibilist and the impossibilist trajectories. I don't know if I answer your question good.
Oh, that's okay.
There's one last question by Sylvie Gauthier. Was the irreversibility an outcome of your modeling exercise, or did you do this upfront, or did you set this upfront? Thank you.
No, it depends. Sometimes you have some rules good to implement the irreversibility, and sometimes it's just the interaction and the multiplication of the interaction in rules. Here, I don't have some rules to make something irreversible. It's just the interaction between rules make the model and the outcome of my model irreversible. And I don't set the irreversibility before. But in some case, if it's needed to really understand the model, yes, we can force the model to an irreversibility outcome. But here is not the case, but we can.
Thank you very much, Boris. Merci bien. We have now a presentation by Maxence Martin. Sorry, did somebody?
Yeah,
Somebody...
Raphael, I just had a quick question because we have 2 minutes, just 1 minute. Boris, you mentioned the spatial scale. I was just wondering at what spatial scale you thought, because, for example, with Yves Bergeron and the PhD with Médicine Nagati, we studied very local changes in dynamic toward either aspen or black spruce. So, what did?
For this model, I just focus on one part, on the forestry part of the Québécois, sorry, on the forest in Quebec, sorry. But the goal of my model is try to understand and input all the rules for a lot of type of boreal forest and try to apply this model on Quebecan boreal forests, on Québécois boreal forest, on Russian boreal forest, or on something else. It's not the case now, but at the end, I hope with this model we can do a lot of things and try to understand the boreal forest at large scale and not in lower scale.
Okay.
But more in all the.
Okay. Well, perfect. Well, thanks.